Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 2, Projection Section Perspectivity, Elementary Configurations. Section 16, the Desargues configuration. A very important configuration is obtained by taking the plane section of a complete space 5-point. The 5-point is clearly a configuration with the symbol 3x3 matrix listed in columns 5, 2, 3, column 2, 4, 10, 3, column 3, 6, 3, 10. And it is clear that the section by a plane not on any of the vertices is a configuration whose symbol may be obtained from the one just given by removing the first column and the first row. This is due to the fact that every line of the space figure gives rise to a point in the plane, and every plane gives rise to a line. The configuration in the plane has then the symbol 2x2 matrix, column 1, 10, 3, column 2, 3, 10. We proceed to study in detail the properties of the configuration just obtained. It is known as the configuration of Desargues. We may consider the vertices of the complete space 5-point as consisting of the vertices of a triangle ABC and of 2 points O1 and O2, not coplanar with any 2 vertices of the triangle. Figure 14. The section by a plane alpha not passing through any of the vertices will then consist of the following: a triangle A1, B1, C1, the projection of the triangle ABC from O1 on alpha, triangle A2, B2, C2, the projection of the triangle ABC from O2 on alpha, the trace O of the line O1, O2, the traces A3, B3, C3 of the lines BC, CA, AB respectively, the trace of the plane ABC, which contains the points A3, B3, C3, the traces of the 3 planes A, O1, O2, B, O1, O2, C, O1, O2, which contain respectively the triples of points O, A1, A2, O, B1, B2, O, C1, C2. The configuration may then be considered in 10 ways as consisting of 2 triangles A1, B1, C1 and A2, B2, C2, perspective from a point O, having homologous sides meeting in 3 collinear points A3, B3, and C3. These considerations lead to the following fundamental theorem. Theorem 1, the theorem of Desargues. If 2 triangles in the same plane are perspective from a point, the 3 pairs of homologous sides meet in collinear points, i.e., the triangles are perspective from a line, by assumptions A and E. Proof: let the 2 triangles be A1, B1, C1 and A2, B2, C2, figure 14, the lines A1, A2, B1, B2, C1, C2 meeting in the point O. Let B1, A1, B2, A2 intersect in the point C3. A1, C1, A2, C2 in B3, B1, C1, B2, C2 in A3. It is required to prove that A3, B3, and C3 are collinear. Consider any line through O which is not in the plane of the triangles, and denote by O1, O2 any 2 distinct points on this line other than O. Since the lines A2, O2 and A1, O1 lie in the plane A1, A2, O1, O2, they intersect in a point A. Similarly, B1, O1 and B2, O2 intersect in a point B, and likewise C1, O1 and C2, O2 in a point C. Thus, A, B, C, O1, O2, together with the lines and planes determined by them, form a complete 5-point in space in which the perspective triangles form a part of a plane section. The theorem is proved by completing the plane section. Since AB lies in a plane with A1 and B1, and also in the plane with A2, B2, the lines A1, B1, A2, B2, and AB meet in C3. So also A1, C1, A2, C2, and AC meet in B3, and B1, C1, B2, C2, and BC meet in A3. Since A3, B3, and C3 lie in the plane ABC, and also in the plane of the triangles A1, B1, C1, and A2, B2, C2, they are collinear. Theorem 1 prime. If two triangles in the same plane are perspective from a line, the lines joining pairs of homologous vertices are concurrent, i.e., the triangles are perspective from a point. Assumptions A and E. This, the converse of Theorem 1, is also its plane dual, and hence requires no further proof. Corollary: if two triangles not in the same plane are perspective from a point, the pairs of homologous sides intersect in collinear points, and conversely. Assumptions A and E. A more symmetrical, and for many purposes more convenient notation for Desargues configuration may be obtained as follows: that the vertices of the space 5 point be denoted by P1, P2, P3, P4, and P5, as in Figure 15. The trace of the line P1, P2 in the plane section is then naturally denoted P12. In general, the trace of the line PI, PJ by Pij, for I and j equals 1, 2, 3, 4, 5, when I is not equal to j. Likewise, the trace of the plane Pi, Pj, Pk may be denoted by L, Ijk, where I, j, and k equals 1, 2, 3, 4, 5. This notation makes it possible to tell at a glance which lines and points are united. Clearly, a point is on a line of the configuration if and only if the suffixes of the point are both among the suffixes of the line. Also, the third point on the line joining Pij and Pjk is the point Pki. Two points are on the same line if and only if they have a suffix in common, etc. Exercises prove Theorem 1 prime without making use of the principle of duality. 2. If two complete endpoints in different planes are perspective from a point, the pairs of homologous sides intersect in collinear points. What is the dual theorem? What is the corresponding theorem concerning any two plane figures in different planes? 3. State and prove the converse of the theorems in Exercise 2. 4. If two complete endpoints in the same plane correspond in such a way that homologous sides intersect in points of a straight line, the lines joining homologous vertices are concurrent, i.e., the two endpoints are perspective from a point. Dualize. 5. What is the figure formed by two complete endpoints in the same plane when they are perspective from a point? Consider particularly the cases n equal 4 and n equal 5. Show that the figure corresponding to the general case is a plane section of a complete space n plus 2 point. Give the configuration symbol and dualize. 6. If three triangles are perspective from the same point, the three axes of perspectivity of the three pairs of triangles are concurrent, and conversely. Dualize and compare the configuration in the dual theorem with the case n equal 4 of Exercise 5, chiefly Figure 15, regarded as a plane figure.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.